in a unit circle to help us graph these. All right? So, before we talk about inverses, we have to talk about restrictions on inverse functions. Okay? So to find the restrictions, the first thing we actually have to do is we have to look at the original and see if it passes the horizontal line test. Okay? So this is where we're going to make a table. X is the angle. Sine of x is like your y value. So we're going to make a table of values, okay? And our table of values we're going to do, because you like them so much, we're going to do in radians. Because you like, will this pass the horizontal line test? No. No, it will not. What we have to do is we have to chop it somewhere to find a chunk that will pass. And it's got to be it has to have something to do with 0, 0. So we have to chop it so it passes. So if I go from negative 2 pi to 0, will this chunk pass the horizontal line test? Whoa, 1, 2, it hits twice right there. So no. How can I chop it so it'll pass?
Negative pi to 0.
Negative pi to 0 won't pass. Good try. Sine inverse is defined if the theta angle is greater than or equal to negative pi over 2, less than or equal to pi over 2. Okay, can we talk degrees then? Let's give it in degrees also. Theta inverse sine will exist when theta is in between negative, what's negative pi over 2? How many degrees? Negative 90 to 90. Very good. Now we're going to do the same thing with the cosine graph. Cosine inverse theta has to be greater than or equal to 0 radians, less than or equal to pi radians. In degrees, what is that, guys? Greater than or equal to 0, less than or equal to 180. Very, very good. So table for y equals tangent x. And then we will graph when we get back together on Friday.